Hello, I'm Paul Beckwith, and of course, this is the main attraction, Shackleton. He's been hiding on me the last few videos, but I managed to find him this time. He's only got so many good hiding spots. So, in this video, I'm going to continue my discussions on the theme of the game of risk and the climate casino. You know, with the jet streams being so fractured and distorted and broken, and extremely wavy in the meridional direction, so going very, very far to the north, going very, very far to the south, and then actually getting stuck in place and having large vortices spinning off of these jet streams. And I called it a blip a few days ago when Washington D.C. got inundated by torrential rains. And now I wanted to talk about some other topics, but New Orleans is under great threat right now. So they had lots of regions of New Orleans had 5 to 7 inches of rainfall just this morning, and there is a tropical storm. Basically, a low pressure area has come across the land. It's been tracked fairly accurately by the European forecasting models specifically, which, much better than the global forecasting system, the US models. And this low pressure area has gone into the Gulf of Mexico, which is very, very warm. It's got temperatures more conducive or more normal in late summer, late July, August temperatures, as opposed to having those temperatures in early July. So this low pressure area has gone into the Gulf and it's curving up, and it looks like it's going to come right into New Orleans at about the same time that they're having huge amounts of rainfall, local rainfall, but also the Mississippi River is cresting again in New Orleans. It's expected to reach almost the height of the levees. And then this tropical storm, which could probably be a Category 1 by the time it hits New Orleans on this weekend, probably Saturday, that combined with the rainfall that they're getting right now, the saturated ground, the cresting Mississippi River, it's just a recipe for disaster. So, we'll see in a few days. But I want to talk about some of the details of this storm and how it's related to abrupt climate change. Okay, so this is my previous blog. Okay, so paulbeckwith.net. If you go to paulbeckwith.net, and I talked all about the game of risk, Washington D.C. submersion, some of the other weird things going on, like the Mexican hailstorm, the change in the regime of the Antarctic melt, what's going on in the Arctic, etc. But let's go to my Twitter feed at Paul H. Beckwith. And basically, I showed this graph here. I showed a graph here of what happens when, if this was the existing weather, this is a new climate, you get a lot fewer cold events, you get a lot more warm events, hot events, and record hot events. But there's also, this is an increase in the mean. So if this is the mean here, the average, and the average goes higher, then the curve just shifts, but it has the same shape. But you can also get an increase in the variance. Excuse me. So if this is the previous climate, in the new climate, this variance, the variability about the average, can increase. So the curve can get a lot wider. It can flatten out like this. Okay, so this would lead to more record cold events and more hot events and record hot events, because it's the area under the curve which is related to the number of events that occur. Now, what happens when you get both an increase in the mean and an increase in the variance? So the increase if this was the previous climate here, then this will be the new climate here. So not only does the mean shift to hotter temperatures, but the width of the curve the curve broadens out. So now you get much less cold weather events, and you get much more hot weather events and record hot weather events. Okay, so we can look at this in terms of, so this is in terms of temperature, but we can also have the exact same curve for rainfall events. Okay, so in rainfall events, because of the shifts of the jet streams and troughs being stuck over certain regions leading to much more rainfall, and ridges being stuck in other regions leading to much less rainfall and drought, you can have a series of curves like this to represent things like rainfall. So the same sort of thing is happening. So right now, the curve has not shifted to a steady state position. That's the problem with abrupt climate change. This is a progressive sort of thing where the curve is continuing to shift, and it will continue to do so until it reaches a stable regime. And it won't reach a stable regime as long as we're getting sea ice collapse and snow cover collapse, for example. The stable regime would be one where there's would be one where there's a final destination where there's no snow and ice in the Arctic, for example. Okay, so we're well on our way in this abrupt climate change transition, but we're nowhere near reaching a stable climate yet, and that will take some time. So we've got all of these things going on in the meantime. This is basically the National Hurricane Center forecast for what is happening with this storm, and this, if it becomes a hurricane, right now it's called Tropical Cyclone 2, potential Tropical Cyclone 2. Okay, and so if it passes this 39 mile per hour regime here, wind speeds, then sustained winds, then it will become a tropical storm and reaches a hurricane at 74 miles per hour. So it's projected to be a hurricane as it comes ashore here, right over just to the west of New Orleans. Okay, and the projection is for Saturday. Okay, you can see the times and the days here, and this is a projection of this storm. So I said there were 5 to 7 inches of rainfall just this morning in that region. There'll be a storm surge from this storm. 3 to 6 feet of flooding is now expected, enough to push the Mississippi River to historic levels. So the concern is the berms that are protecting the city. So this is a very good tweet here showing a map of New Orleans. Okay, so here's New Orleans sitting here, and this is a sort of ground elevation cross section. So we've got the Mississippi River here, and the berms go up to about the 20-foot mark. Okay, so if we go much above 20 feet, these berms will be overtopped. The problem is when the water runs over the top, it starts cutting away at the soils behind, and then the whole thing can collapse and get washed in, and you get breaches of the berms. This is on the Lake Pontchartrain shoreline side, so salt water. This is sort of the level here where we're at, and this is the berm. These are the berms that failed in the previous flooding of New Orleans, and you can see, different streets and so on at different levels, and it's basically like a empty bathtub at the moment, and will the water stay out? Also, we're getting lots of rainfall over this region. I mean, the big risk from this Hurricane Barry is that it dumps enough rainfall to increase the levels of the river, the Mississippi River, and overtop the barriers, but also overtax the pumps just from the rainfall in the particular inside the bathtub itself, let alone water coming in from either side. So it's an extremely risky situation. This is the Mississippi River at New Orleans. The anticipated flood levels here. So 9 a.m. Saturday, maybe Saturday noon or afternoon, expecting to reach about 20 feet. And that's the height of the protections, the height of the berms. So we've got an extremely dicey and risky situation here, which again leads to the, climate casino idea, the game of risk idea. Okay, so we could have potentially a massive problem here, with New Orleans. So the governor of Louisiana, by the way, Nola, some people don't know what that means. It stands for New Orleans, Louisiana. The governor has declared a state of emergency for this situation. This is a good graphic here of where did this storm come from. So the storm here is you can see it tracking here. This is from the European model, starting from basically from July 4th, tracking to the present. So the last week of tracking of this storm, it's been anticipated to do this. I mean, the model has forecast very accurately what it's doing, and now it's going to curve up and come ashore here as a likely Category 1 hurricane called Barry on the weekend. So very good depiction, and there's lots of other things in Twitter. If you look at my Twitter feed, here's some flooding from this morning, downtown New Orleans, from the 5 to 7 inches of rain that fell in 2 hours. Okay, it caused this sort of flooding. So now when we talk about 2 feet, 24 inches of rain coming, in a short period of time from this tropical storm / Hurricane Barry, and combine that with the flooding, reaching the 20 feet flood level of the Mississippi River, and there's a lot of factors against New Orleans right now. Okay, so this is a storm this morning, and this is the idea of the stationarity of these weather patterns. Okay, so the weather pattern here this morning, you can see the time here. This is from Radar Scope, a movie of the storms, and this is intense rainfall over this whole region, including the Mississippi Basin over this side coming into New Orleans. Okay, so it just got stuck and didn't move and dumped that 5 to 7 inches, up to 10 inches over some areas this morning. So extraordinary things are happening right now. Now I want to show you this site, Tropical Tidbits. If you're not familiar with this website, it's worth looking at. So look, I've clicked on current. This is current storms, so it's showing the and you can click on any of these things to enlarge it, the different models and so on, what they're projecting for this storm. Okay, you can just click on any of these things and you can see the projected path of this present system. Okay, let's go back. Okay, there's all kinds of information there. You can get aircraft reconnaissance data on the system. Okay, you can get satellite imagery. Lots of satellite imagery, for example. So here on United States, so we're looking at the, okay, this is the cycling of the weather patterns. This is long wave infrared radiation showing the storm. Okay, so there's also different, you can look at the different models, the thermodynamics, 2-meter temperature anomaly, for example, upper dynamics up where the jet stream is, 250 millibar winds, lower dynamics of the atmosphere, a couple kilometers above, precipitation, moisture level. There's all kinds of stuff. Total accumulated precipitation so far, for example, right? You can see all of these different things here. Okay. Okay, and you can play them as movies and so on. So it's a great site. So check it out, Tropical Tidbits, tropicaltidbits.com. And I'm going to do a second video and look at some of the details on this particular event.